Let us define what is composite function. If f is a function from x into y and another function g from y into z, then the composite function g of f is a function from x to z, and this function is defined by g of f of x equals to g of fx, and this is happen for all x in x. So if you look at the two functions f and g, they share set y in common. The codomain of f, you can see it is the domain of g. Then if you combine or merge those two functions, we will now have a new function that will pick elements in the domain of f and assign those elements to the elements in the codomain of g. So that new function is called the composite function. If you have composite function g of f of x, meaning the composite function of x is now equals to g of fx, and this happens for all x in x. Example, if we let f to be a function from x into y and the g is another function from y into z, and those two functions are defined by the diagram below. Look at the diagram. If we ask now to find g of f of a, so we are to find the image of a under this composite function. What we simply do, we now set this is the center as g of f of a, and the g of f of a is nothing but g of 2. Look at it from the drawing. The image of a under the function f is 2. Then we'll continue to get the image of 2 under the function g. So you can now see that the image of 2 under the function g is now 30. So entirely the image of a under the composite function will now be equals to 30. We can continue to find the g of f of c. F of c is what we get first, meaning the image of c under the function f. The image of c under the function f, if we trace it, we can see that it is 0. So therefore g of f of c is nothing but g of 0, and the image of 0 under the function g, look at it, is the element 10 in set z. So therefore the image of c under the composite function is now 10. Finally, we asked to find the image of e under the composite function, that is g of f of e. That image is nothing but g of f of e. So first get the image of e under the function f. The image of e under the function f, if you look at the drawing, you can now see it. It is 6. 6 is the image of e under the function f. And that element 6, it is image under the function g is now 70. So finally the image of e under the function, under the composite function, is now 70. This is how we now do to get image under the composite function. We take more examples. Example number 1, it says if we have the function f, and that function f is defined by the formula f of x equals to 2x squared plus 5, and another function g, and that function g is defined by the formula g of x equals to 4 minus 7x. The question asked here is to find question A, f of g of 2, question number B, g of f of 2. So solution to this problem, starting with the question number A, we asked to find f of g of 2. F of g of 2 is nothing but, look at it, it is f first. So we now have f of g of 2. So you can see g of 2 in the bracket. It is inside inner bracket. So we have to get g of 2 first. So if we continue, I will now get the image of 2 under the function g first. So what I'll simply do to get the image of 2 under the function g is to go to the formula for the function g and substitute x by 2. So substituting x by 2 in the formula for the function g, remember the function g is defined by the formula g of x equals to 4 minus 7x. So that x and 7x will now be replaced by 2. So I'm going to have f of 4 minus 7 multiplied by 2. So I'll multiply 7 by 2 first. So I'll have minus 7 multiplied by 2. It will give me minus 14. And minus 14, I'll have 4 minus 14 there. Our final answer will be minus 10. So I'll now have f of minus 10. So next I will do, I'm now trying to find the image of minus 10 under the function f. So what I'll simply do, I'll go to the formula for the function f and substitute x by minus 10 there. And the function f, remember, is defined by the formula 2x squared plus 5. So substituted x by minus 10, I'm going to have there 2 into minus 10 raised to the power of 2, then plus 5. And minus 10 squared, remember, is 100. So I have 2 multiplied by 100, then plus 5. After multiplying 2 by 100 and adding the result to 5, the final result will now be 205. So this 205 is the image of 2 under the composite function f of g. I can now move to answer question number B. Question B asks us to find g of f of 2. You can see it's the same element 2 in question A and in question B. But in question A it is f of g, while in question B it is g of f. These two are two different composites. So g of f of 2, meaning the image of 2 under the composite function g of f, is nothing but g of f of 2. So you start with the f. The last function there will now be the function in the innermost bracket. So g of f of 2, I will get first the image of 2 under the function f. The function f is defined by the formula f of x equals to 2x squared plus 5. So I'll go to that formula and substitute x by 2. So I'm having now g of bracket 2 multiplied by 2 squared and plus 5. I have replaced the x by 2 in the function f. So simplifying this result, 2 squared will be 4. That 4 multiplied by the 2 will give answer 8, and 8 plus 5, the answer will be 13. So I'm now getting the g of 13, meaning the image of the element 13 under the function g. So I'll go to the formula for the function g, which is 4 minus 7x, and substitute x there by 13. So I'm now going to have 4 minus 7 multiplied by 13. I have replaced the x in the formula g of x by 13. So multiplying minus 7 by 13 and adding that answer to 4, the final result will be minus 87. Therefore, the image of 2 under the composite function g of f is now minus 87. Another example is said, let the function f be defined by the formula f of x equals to 2x minus 1, and another function g defined by the formula g of x equals to x plus 3 all over 2. If we have those two functions, the question asked here is to find a f of g of x and b g of f of x. Solution to this problem, starting with the question number E, that we asked now to find the f of g of x. F of g of x is nothing but f first, then g of x. So you have f of gx. But g of x, remember, we have the formula for g of x as x plus 3 all over 2. So there what I will simply do, I will now substitute g of x by that formula. So I'm going to have f of the bracket x plus 3 all over 2. I have replaced the exactly g of x by x plus 3 all over 2 because g of x is nothing but x plus 3 all over 2. So next I'll continue. I will now find f of x plus 3 all over 2. So what I will simply do now, I will go to the function f, the formula for the function f. Anywhere I have x in the function f of x, I will replace it by x plus 3 all over 2. So I'll continue. So the formula for the function f is says 2x minus 1, meaning 2 multiplied by x then minus 1. So I'm replacing that x by x plus 3 all over 2. So I'm going to have 2 into x plus 3 all over 2, then minus 1. So I continue. You can now see that that 2 outside the bracket will cancel with the 2 at the denominator level. So I'm going to have x plus 3 minus 1. And this x plus 3 minus 1 simply is the same thing as x plus 2. Therefore, the composite function f of g of x is nothing but x plus 2. We can now move and answer question number B that we asked to find the g of f of x now. It is g of f of x now. This is another different composite function. It is g by f, but the first one is f by g. So let us move. G by f of x is nothing but g of fx. So what I will do next is to get the function fx. The function fx, remember, is there defined by the formula 2x minus 1. So I'm going to replace the fx by 2x minus 1 because fx equals to 2x minus 1. So I will now have g bracket 2x minus 1. Next is to get g of 2x minus 1. So wherever we have x in the function g, we replace it by 2x minus 1. So look at the function g. And the formula for the function g is x plus 3 all over 2. So that x is now replaced by 2x minus 1. So I'm going to have 2x minus 1 then plus 3 all over 2. There I collect like terms. The 2x minus 1 plus 3, the minus 1 plus 3, the answer will be plus 2. So I'm going to have 2x plus 2 all over 2. And if I continue, the 2 in the numerator level, we can factor 2 outside. So there we are going to have 2 into x plus 1 all over 2. You can see those two, the 2 outside the bracket will cancel the 2 at the denominator level. So I'm going to have finally x plus 1. Therefore, this composite function, that is g by f of x, is nothing but x plus 1. Another example, it says let the function f defined by the formula f of x equals to square root of 2x plus 1. And another function g defined by the formula g of x equals to x squared plus 3. The question asked here is to find the composite function f by g of x. And the question also says we should use it to find the image of 3 under that composite function f of g. Solution to this problem: f of g of x is nothing but f of gx. So the gx is defined by the formula x squared plus 3. So I'm going to replace the gx by x squared plus 3. So I'm going to have f bracket x squared plus 3. Now I'm to find the image of x squared plus 3 under the function f, which means I will go to the function f, the formula for that function. Anywhere I have x, I will replace it by x squared plus 3. So the function f is defined by the formula square root of 2x plus 1. So therefore I'm going to have square root of 2 into x squared plus 3 then plus 1. That bracket, what is inside the bracket, that is x squared plus 3, is nothing but the x in the function f. I have replaced the x in the function f by x squared plus 3. So opening this brackets, that is 2 multiplied by x squared multiplied by 3, I'm going to have square root of 2x squared plus 6, then plus 1. And collecting like terms, the 6 and 1 are alike. You can add them to get 7. So I have finally square root of 2x squared plus 7. And this is the formula for the composite function f by g of x. But the question says that I should use this to find the image of 3 under that composite function. So the image of 3, what we simply do is to replace the x by 3 in the formula for the composite function. And the formula for the composite function is square root of 2x squared plus 7. So f of g of 3 is nothing but replace the x by 3 in the formula. So we have been square root of 2 into 3 squared plus 7, and the 3 squared is 9. Multiplied by 2, the answer will be 18. And 18 added to 7, the answer will be 25. So I have square root of 25, and square root of 25 is nothing but plus or minus 5. And therefore, the image of 3 under the composite function f of g is nothing but plus or minus 5. And this is the end of this lesson. Let us now revise some of the things that you have learned in this lesson. In this lesson, you have learned that if f is a function from x into y, and another function g from y into z, if these are two functions, then the function that will pick each and every element from x into z is called the composite of g by f. You have also learned in this lesson that if g and f are two functions, then g of f is nothing but g of fx. And also you have learned in this lesson if f and g are two functions, and you are asked to find the composite function f of g of x is nothing but f of gx. These are some of the things you have learned in this lesson.